Let's go ahead and take a look at your warm-up for today. So you were asked to identify the vertex and axis of symmetry, label the vertex axis of symmetry, and the intercepts on the graph that you create. So first thing we need to do is complete our table, then graph it, and then identify the important pieces. Let's go ahead and start by looking at our equation for A. I see three important pieces. I see that A is 1, H is 2, and K is 4. So without doing any math, I know that this middle box in my table is going to be 2, 4. Because I know that A is 1, I also kind of know that these gaps are going to be predictable. But let's go ahead and do some calculations to show what those numbers should be. So I'm going to start with this x equals 0 box. And we know that's going to be 1 times 0 minus 2 squared plus 4. So I'm going to start with the parentheses. 0 minus 2 is minus 2. Next step with PEMDAS, I have to do the exponent. And I know that negative 2 times itself is going to be a positive 4. 1 times 4 is 4, and 4 plus 4 is 8. So that first box should be 8. Let's go ahead and try that again with our next box. So for our next box, we see that x is equal to 1, and we're going to do that same substitution process. So 1, I'm replacing x with the 1, minus 2 squared plus 4. We start with parentheses first. So 1 minus 2 is minus 1. Then we do the exponent. Minus 1 times itself becomes positive 1. 1 times 1 is 1, and 1 plus 4 is 5. So that next box should be 5. And that makes sense. We know for a parabola where A is 1, there should be a gap of 1 between the vertex and the next point, and then a gap of 3 between that and the next. So this does match that pattern we've seen before on quadratics that don't have a dilation factor. I also know that with quadratics, they're U-shapes. So on the other side of this table, we get 5 and 8. So I'm going to graph that really quick, and let's take a look at what that looks like. You'll notice 0 and 8 don't quite fit, and 4 and 8 don't quite fit. So I'm just going to sketch the U shape that I have. Let me try again. That was a little messy. Close enough. We'll take it. And we're going to go ahead and identify and label. So let's start with our vertex. So we know our vertex is at the bottom or top of the parabola. We also know it's our h and k, so this should be 2, 4. And we know the axis of symmetry is an equation of the line that cuts this parabola in half. And it's always x equals the x-coordinate of our vertex, so 2. And I'm going to go ahead and draw that in our graph. And label those two things. So this line is the line x equals 2. This is the point 2, 4. And the last two things they ask us about aren't visible on our graph. This parabola doesn't have an x-axis. It never crosses this line. And the y-intercept is up off the graph. we do know from our table that our y-intercept is going to be at 8. We just can't see it on our graph. Okay, so let's go ahead and try the next one. We're going to do that same process. We're going to start by identifying our vertex and looking at those factors. So A is 1/2. This is going to be a wider, flatter parabola. H is going to be -1. H changes sign. And K is -2. So first entry in my table, H is -1, K is -2. And this time I'm going to do the plug and chug without writing it out. So I'm going to actually do the bottom half of the table. I think those positives will be easier. So 1 plus 1 is 2. 2 squared is 4. 4 divided by 2 is 2. And 2 minus 2 is 0. And then for 3 plus 1 is 4. 4 squared is 16. 16 divided in half is 8. And 8 minus 2 is 6. Now that we've got the bottom half filled in, we know the top half should be the mirror of those points. So 0 and 6. And now we're ready to start graphing. Lucky for us, all of this does fit on the graph. So -5 and 6, -3 and 0, -1 and -2, and then their mirrors on the other side. Oh, that is a horrible curve, Mr. Jolliffe. Let's try that again. So sorry my digital U is not that pretty, but we get the idea. We see that U, and we can see comparing that parabola to the one in A that it's much wider because our dilation factor is 1/2, and we know that dilation factors that are less than 1 result in a wider parabola. So last step, let's go ahead and label things. We know our vertex from our table. We know that that's -1, -2. We know our axis of symmetry is going to pass right through that vertex. So we know the equation for that line is x equals h. And then the intercepts, I see one right here, one right here, and one right here. So I know that my x-intercepts are -3, 0, and 1, 0. I can see those in my table. This one's a little bit harder to identify, and it doesn't look very pretty in my graph. But based on patterns we've seen before, I know that that's going to be 0 and -1.5. Because I know that the dilation factor tells me that vertical gap between my vertex and the point that's one x value over. So this tells me my second point, the one right next to the vertex, so at -2 or at 0, is 1/2 above where that vertex is. If you didn't remember that, it's okay, but you should at least be able to identify that this point is a y-intercept because it's where the curve crosses the y-axis. Okay, so let's go ahead and really quickly discuss some of the things that you're going to see on your quiz today. I want to make sure that we're nice and ready for our quiz. So the first thing that you need to know for your quiz today is if you're given an equation in vertex form. So for example, 2x minus 1 squared plus 5, you should be able to describe the features of that parabola. So we know that h and k control translations or shifts in the parabola. So h tells us whether the curve is to the left or the right. In this case, h has the opposite sign in the equation, so h is 1. So this is going to be a shift to the right because h is positive. K controls shifts up and down. If it's positive, it's up. If it's negative, it's down. In this case, it's up because K is positive. Specifically, I know it's going to shift right 1 and up 5. The last thing we look at is whether there's been a reflection and a dilation. And both of those are controlled by A. Since A is positive, there's no negative in front. This is a happy face parabola, and it has not been reflected. So this guy opens up. So opens up means happy face. And because there is a number that is bigger than 1 in front, we know that this is going to be a narrower parabola. So you're going to be asked to do that for the first page of your quiz. And it's going to look a little different for each question, but they're all asking the same thing. Does it shift left or right? Does it shift up or down? Is it happy face or frowny face? Is it narrow or wide? So this is the first thing that you need to remember. You may want to take a second and jot that down on your note card. The other thing you're going to be asked to do today is identify key features of the graph and graph from an equation. And those are the two things that we just practiced in our warm-up. So for identifying features, there are a few things that we're looking for. First, you should know how to pick out the vertex. We know that that's h comma k. Second, you should know how to pick out your axis of symmetry. That's the equation x equals h. That's the line that cuts it in half. And then you should be able to pick off x-intercepts and y-intercepts from the graph. Remember to graph the parabola. When you make your table, x and f of x, and you're trying to find points to create your graph, that if you've got 5 boxes, 7 boxes, 9 boxes, that middle box should be the vertex. So in this case, if you've got a table with 5 rows, 1, 2, 3, 4, 5, we want the vertex in the middle so that we get both sides of the U. So for example, if I'm trying to graph this equation over here, I want 1, 5 in the middle of that table. My x's would then be numbers on either side. So 0 and -1, 2 and 3. You don't have to do this, but it is going to make graphing easier because it'll show you both sides of the parabola. Okay, Ms. Nieves and our guest teacher are going to get you started on your quiz. Good luck, do your best, and remember not to leave anything blank. And I will see you on Friday.